This illustration analyzes a pulley system on support brakes. Here we already discussed in concept video various cases in which whether a spring or a string is cut, the whole system suddenly changes in forces and few blocks may attain some acceleration and few may be kept at rest. So here we analyze similar such situation where the figure shows 3 blocks in equilibrium in a pulley system supported by a spring, and it says if a string 1 snaps, we are required to find the acceleration of 3 blocks just after a string snaps. So here in solution we first need to analyze the forces in equilibrium situation. Let's have a look on this figure where if we consider tension initially in string 2 is say T1 and a string in the tension in a string 1 is say T2. So for 3 blocks if we consider at equilibrium, if we draw a free body diagram of blocks, then we can see for block A, it is experiencing a downwards spring force, say it is Kx, plus its weight mg, and the upward force is due to the string tension which is T1. For block B, its weight is in downward direction 2 mg plus a string tension T2 is acting on it, and in upward direction it is T1. And for block C, here downward is its weight mg and upward is the string tension T2. So for equilibrium we can write the value of T2 as mg. For block B we can write T1 is equals to 2 mg plus T2, which will be 3 mg. For block A it is T1 is equals to Kx plus mg. So if we substitute the value of T1 here, the value of Kx we are getting is 2 mg. This is the force acting on the block due to a spring in downward direction. Now if string 1 snaps, if this snaps, that means suddenly the tension T2 will go down to 0. Tension T2 becomes 0 suddenly, because as it snaps, the remaining parts of the string upper and lower will get a slacken and no tension will be there in it. So block C we can directly say it will be in free fall, so we can directly state, and block C will now be in free fall. This implies the acceleration of block C will become g in downward direction suddenly. Now if we talk about block A and block B, obviously here if we consider if tension in a string 2 changes to T prime, then we use just after 1 snaps, so this block starts going down with A and this goes up with acceleration A. So we can write the equation for these blocks as for A we can write downward force on it as Kx plus mg. So that will be 3 mg and upward force is T prime, because the tension T1 changes to T prime. So here we can write 3 mg minus T prime is equals to ma, and for block B we can write T prime minus 2 mg is equals to 2 ma. And in this situation if we add these equations, here T prime gets cancelled out, we are getting mg is equals to 3 ma, where m gets cancelled out, and we are getting the value of A as g by 3. That means just after string 1 snaps, acceleration of B is g by 3 in upward direction, and acceleration of block A is g by 3 in downward direction. So these are the final results for this problem.